As we head into the fourth unit, biochemistry, we're going to start off with talking about smell and functional groups. Our first question is, how do chemists classify smells? Smells are super important to survival, and they're also, really big money makers around the world with perfume sales and deodorant and, all the stuff that smells nice, candles and whatever. So we're going to talk about how smells are classified scientifically. Smells are classified through smell classifications, which basically are just general terms that describe a group of smells. So we're going to talk about the five major smell classifications. There are others because not everything that we smell is going to fall under these five classifications. But we're going to talk about five of these smell classifications and tie them into biochemistry and big carbon-based molecules. All right, so here are the five ones that we're going to focus on. So if we say something smells putrid, it's repulsive, it's gross, we're talking nasty. All right, so putrid is one smell classification. The next smell classification that we're going to use is camphor, which is a smell that smells kind of medicinal, like medicine-y, or herbal, kind of earthy or medicine-y, is camphor. Now, sweet is given to anything that is, smelling like flowery or fruity of some kind. And let's see, our next one is minty. Minty classifications is for something that, smells minty. I don't know another way to describe it well. And then our last one, fishy, is anything that smells, fishy. So these are the five smell classifications that we're going to kind of look at as we go through these biochemical molecules. The last thing that we're going to talk about in this question is the proper way to smell things, because we're going to be smelling things starting tomorrow. And so we need to remember the proper technique for smelling any kind of chemical is to waft, right? Just like we saw in the little video at the beginning of the school year, when it's like, waft with me, waft with me. Okay, so it's the proper way to smell chemicals. We don't just stick it right up in our nose, because some chemicals could cause you to pass out. What we do is we, bring the fumes close to our nose by waving our hand from the vial towards our nose. Okay, so that's called wafting. So when we start smelling things tomorrow in class, then you're going to definitely want to do the wafting first before you just stick it right into your nose. All right, so let's take a look at the second question. Is why do substances smell different? All right, so you may have noticed that different substances smell differently. So we're going to take a look at one of the reasons why substances can smell different. And what it is related to is the arrangement of atoms within the molecule. And that's exactly what a functional group is. The functional group is a certain arrangement of atoms in a molecule. So we're going to take a look at the functional groups that give us the different kinds of smells that we talked about in the first question, the putrid, the camphor, the sweet, minty, and fishy. So we're going to take a look at which functional groups give us molecules that smell like those first five smell classifications. We're going to take a look at four different things here for each of the different smells. We're going to take a look at the smell name, the functional group, name that it's associated with, the structure of that functional group, meaning what it looks like within the molecule, and then the name ending, because molecules, we'll see, are going to have a name ending that is associated with their functional group. All right, so let's take a look at the first one, which will be minty. Okay, so the first smell is minty, and minty substances have a functional group called a ketone. Okay, now the structure of a ketone is something like this. So we have a carbon double bonded to an oxygen, and then we have carbons on either side of it. Okay, so that's the structure of a ketone. It's the carbon double bonded to the oxygen with two carbons on either side of that middle carbon. That's what a ketone is. Now, if we take a look at the names of things that smell minty, most of the time they're going to be ending with O-N-E. Okay, just like ketone ends with O-N-E, the name end will also end with O-N-E, just kind of give you a hint about the functional group that is in the molecule. All right, the next one we're going to talk about is fishy. Okay, so that's our next smell, is the fishy smell. The functional group name is called an amine. Okay, and an amine is rather simple. It's a carbon that's just bonded to a nitrogen somehow. All right, and I'm leaving all of these little lines blank because there could be anything. There'd be hydrogens, carbons, any kind of atom here, on these parts right there. So that's why I left them blank. An amine is very simple. It's just a carbon with a nitrogen attached to it. And that usually will make something smell kind of fishy. Now, when we take a look at the molecular name of these substances, these will end in INE. Okay, just like amine ends in INE, so will the molecule name. All right, our next one we're going to talk about is putrid. Let's put that one in brown. Putrid, remember, is the repulsive smell. And for most things that smell putrid, it's because it has a functional group called a carboxylic acid. So carboxylic acid. Now, this is how the structure of a carboxylic acid works. You're going to have a carbon double bonded to an oxygen, but you also, on that same carbon, have attached a oxygen that is attached to a hydrogen, so it's very specific. Okay, so C double bond O, OH. All right, now, if you if you look at the molecular name for things that smell putrid, it usually ends with ic acid. Okay, just like carboxylic acid is gives you a clue about the functional group within the molecule. All right, so let's keep on going down to sweet. Okay, we'll do sweet here. Okay, sweet smelling molecules, flowery, fruity kind of molecules, are usually because within the molecules that make it up, we have a functional group called an ester. Okay, an ester is a carbon double bonded to an oxygen. Okay, and now we also again have an oxygen, but instead of an H like we had in carboxylic acid, it's another C. Okay, so, and everything else can be, it doesn't matter whatever else is on these things here, just as long as we have that carbon double bonded to oxygen, and then the oxygen and another carbon. Okay, I kind of like to call it the cookie, little thing. I know it's cookie spelled C-O-O-K-I-E, but if we spell a little wrong, we can see C-O-O-C. Okay, so ester is that little cookie arrangement. Now, molecules that have an ester in it usually are going to end with ate, ate. Okay, obviously unless it's like a polyatomic ion or something like that. But for the most part, if we take a look at some examples, we'll see that the sweet-smelling ones end in ate. Okay, so that one doesn't really go with the ester name, but a little, saying that I always kind of throw out there is Esther ate the sweet cookies. Kind of how you can think about, all of these four things together. Esther ate the sweet cookie. All right, our last one that we're going to do is camphor. Okay, so this is our last one, our fifth one. So our last smell is a camphor smell. And the functional group for camphor is an alcohol group. Okay, an alcohol group is very simple. It's a carbon, okay, with an oxygen and an H. Okay, so COH is an alcohol group. All right, this carbon can be singly bonded to any other types of atoms here. So that's why we leave them blank. As long as we have a carbon with an oxygen and a hydrogen, and no double bond of any oxygens anywhere else on that carbon, then we've got an alcohol group. And the name ending for these molecules goes along with the usual functional group that we saw earlier, OL. Okay, so just like alcohol ends in OL, any camphor smelling or medicinal smelling substances are going to end in OL. All right, the very last thing that I want to say about these functional groups is that these functional groups, or the different arrangements and bond types within a molecule, produce different physical properties, okay, like smell. Okay, so that's important. Another thing that's important is that they also produce different chemical properties as well. So that's going to affect what kinds of reactions they're going to undergo. And so we'll see that when we do our smell lab next week. For now, that's the end of these notes, and we'll see you tomorrow. Be sure that your nose is ready to smell stuff.